Okay, this is chapter 14, part 2, lecture 2, segment 3, and we're going to be talking about buffer capacity. Now, this is not type written into your lecture guide, but it's important to think about the chemical reactions of buffers with added acid or base before we get into working with ice tables and things like that. So, buffer capacity is basically how much acid or how much base a buffer can absorb before just getting completely out of whack. Now, normally we calculate the pH of a buffer using the Henderson-Hasselbalch equation. Okay? And remember again that the acid or the base could be concentrations or moles. And the base to acid ratio, if it's 1, the pH is going to be equal to the pKa of the acid. So, for example, if we're talking about acetic acid, the pH would be equal to the pKa, which is 4.74. Right at the midpoint when you have equal amounts of acid and base. Now, there's a certain pH range that a buffer operates in, okay? So the pH range of a buffer is plus or minus 1 pH unit. So if the pKa of acetic acid is 4.74, we can make a buffer that has a pH from 3.74 to 5.74, right? So I get this first number by doing 4.74 and subtract 1. I get this number here by 4.74 plus 1, okay? So, the midpoint here would be 4.74. So 1 pH unit lower would be 3.74. 1 pH unit higher would be 5.74, and so this is going to be your pH range. It's going to be plus or minus 1 pH unit from whatever pKa of the weak acid is in your buffer. So therefore, what this means is that the base to acid ratio, okay, is going to vary, okay, for the 4.74, that's going to be, 1 to 1, right? And for pH 5.74, that's a higher pH, which means more base. It's going to be a 10 to 1 ratio, okay? Log of 10 to 1 is, 1, right? So if you plug it into the Henderson-Hasselbalch equation up above, you'll have 4.74 plus 1. And if the pH is equal to 3.74, right, it's going to be 1 to 10. And so, again, log of 1/10 is minus 1. So if you plug it into the Henderson-Hasselbalch equation, it'll be 4.74 minus 1, okay? So if a buffer is useful with a plus or minus 1 pH unit, this means that your base to acid ratio must vary from 10 to 1 to 1 to 10. Okay, so that's kind of like the maximum, okay? And so we want to now think about buffer capacity. Buffer capacity, it's different than buffer range. Buffer capacity is how much hydroxide ion or H plus ion can react, okay? How much OH minus or H plus ions in a buffer it can react with, okay? So for example, if we have a buffer that's composed of lactic acid, which is 0.250 molar, and sodium lactate, of 0.250 molar. This is the acid. This is the base. Okay? And we can see that we can react with 0.250 molar hydroxide. Okay? All of those hydroxide ions would be eaten up by the acid and converted to, the conjugate base. And since the base is an equal concentration, we could react that with the same amount of H+. So that would be the maximum amount of H+ that could be absorbed by this buffer, and the maximum amount of OH-. Okay, let's look at another example. Again, we have the same buffer. I'll just write acid and base. So the lactic acid is 0.250 molar, and the sodium lactate, or the base, is 0.125 molar. So you can see how these are unequal. The acid reacts with OH. It can react with a maximum amount of 0.25 molar hydroxide. Okay, so it has more buffering capacity against hydroxide than acid. And this can react with a maximum amount of hydrogen ions, okay, less. So this buffer is going to have a certain pH, and you can see here how it can react, and it's buffered more against base than it is with acid. Let's look at a third example. Okay, the acid is 0.250 molar, and the base is 0.0800 molar. And so again, this is 0.250 molar. This is the acid, which reacts with hydroxide. We can react with a maximum amount of this much hydroxide. And the base, it has very low concentration. This can react with 0.0800 molar H+. Now, I'm assuming that all of this reacts. If you really wanted to be technical about it, you could figure out 9/10 of that or whatever, because it's going to be 1/10 or 10-to-1 ratio. But I'm just assuming it all reacts to give you an idea of the buffering capacity. Okay, it would technically be less than this amount of hydrogen ions, but that's what I'm just guesstimating and estimating here, and that's what you should do in your try it now problem. Okay, so the question here again is what is the buffer capacity of a buffer made of 0.125 molar acetic acid and 0.300 molar sodium acetate with respect to hydroxide ions and part B, H+ ions. Okay? So enter those on your worksheet, and you'll have completed this segment. Thanks for watching.